Log of 2 with a base of 3 is not a rational number. So let's check that if this particular statement is true or not. So we'll suppose that let log of 2 with a base of 3 is a rational number. So we are starting with a contradiction. Even though we have to show that this is not a rational number, we assume that it's a rational number. That it means log of 2 with a base of 3 can be expressed in the form p over q, where q cannot be equals to 0 and p and q do not have any common factors. Now we can use the definition of logarithm. So let's state the definition. If we have log of a with a base of b, and this is equals to c, then it's also equivalent to saying a equals to b raised to the power of c. So that means we have 2 equals to 3 raised to the power of p divided by q. Now what we'll take? We will take the power as q on both sides. So we have 3 raised to the power of p over q whole raised to the power of q. So this gives us 2 raised to the power of q equals to 3 raised to the power of p. Now this is an invalid statement. They cannot be equal because 2 raised to the power of q, this gives us a even natural number, and 3 raised to the power of p, this gives us an odd natural number. Then how can be an even natural number or be equal to an odd natural number? So this is a contradiction. So since we are getting a contradiction, we say that our statement that we started out with log of 2 with the base of 3 is a rational number is a false statement. We can say the log of 2 with the base of 3 is not a rational number.